The universe is not static. It evolves all the time and grows in all directions. It's expanding, and scientists found this out almost a century ago. And it's not at a stable rate. The more time goes by, the faster the universe expands. As this happens, stars, planets, and galaxies move farther and farther apart, which leaves more space between them. If that's the case, the universe is supposed to become colder as it expands, right? After all, it was a lot denser when the Big Bang happened, and a lot hotter. As it was expanding, space was cooling down, which created conditions for planets, stars, and other space objects to form. Yeah, that's not exactly the case now. Scientists were surprised to hear it too. But our universe is actually getting hotter. They observed the temperature of cosmic gas farther away from our home planet compared to young gases closer to the Earth. Since we measure distance in space by light years, farther areas are like going back to the past, and regions closer to us are like observing the present day. They found out the temperature of a gas in space has gone up more than 10 times in the last 10 billion years. Now, the temperature of the cosmic gas that's spread all across the universe can get to around 4 million degrees Fahrenheit. Wow! As the universe expands, gravitational force does its part and pulls gas and dark matter together. It's doing some pretty hard work there. It creates galaxies and clusters of galaxies out of them. And this process is totally chaotic. It's so messy that more and more gas heats up as all of this is happening. Space was extremely hot when it was just forming 13.7 billion years ago. What if it gets warm like that once again? Scientists are observing the situation. They found out the temperature in space increased by measuring cosmic gases using something called redshift. They generally use this method when they want to see how far away some space objects are. Those that are closer to us have shorter light wavelengths. The farther some object is, the longer its light wavelengths are. And they can now determine the temperature of a certain object from its light. On average, space is a pretty cold place. The glow that's left from the Big Bang is called the CMB, which is short for the cosmic microwave background. It's so powerful and intense, it bathes the entire universe in light. It's the only thing that significantly heats up matter. But there are many smaller mechanisms that help to heat up matter in the universe, and they could go crazy if space warms up. Like stars. They emit radiation that affects nearby dust and gas. They radiate throughout the far infrared too. When a star is at its early stage, the radiation coming from it forms protoplanetary structures that look like disks. They primarily form in a single plane, and a bright central star produces spectacularly illuminated gas, and there are blue reflections of this gas. It was like that with our planetary system too. Strong energy and gravitational forces cause collisions, dust, and gas in an uncontrolled vortex that's forming planets. That's why most planets in our solar system orbit in the same direction. That's the direction this giant whirlpool was spinning a long time ago too. Active stars, colliding galaxies, stellar cataclysms, black holes, neutron stars. The universe has so many sources of energy. And when you surround normal matter in space with such an energetic environment, it heats up drastically. When you heat something up, it radiates that energy away in a certain way. In most cases, galaxies have just a couple of areas where stars are forming, at regions where gas is collapsing. A bubble that surrounds that area contains ionized hydrogen. 3/4 of our sun is hydrogen. Thanks to that hydrogen, the sun keeps us warm. In its core, hydrogen transforms into helium and causes atomic fusion. Yep, that's how our sun releases its energy. Radiation heats all that gas to thousands and thousands of degrees. At the same time, it ionizes a large number of atoms and molecules, which basically means it turns them into ions. Atoms are neutral particles, and ions are either negatively or positively charged particles. If the universe heats up, our sun might too. If its temperature hits 30,000 degrees Kelvin, it could become hot enough to ionize all those materials it had previously ejected, and it could create a real planetary nebula. This would be a nebula in the shape of a ring that forms because of an expanding gas that surrounds an aging star. As the temperature goes up all the time, hydrogen ionizes. At a few thousand degrees, this could turn the nebulae in our solar system pink with emission lines. Our sun could come to its end if it reaches the temperature of 50,000 degrees Kelvin. If you could float in space and come closer, you'd see it glow in eerie green tones because of doubly ionized oxygen. Higher energy phenomena make more galaxies collide. This heats gas even more and eventually results in X-ray emissions. What about black holes and radiating neutron stars? When they go crazy, they can shape whole galaxies, and who knows what more. Maybe we'd have more masers too. Those are natural lasers our universe produces. They arise when big populations of molecules receive large amounts of energy. By now, scientists have found the strongest, yet the most distant maser. So powerful, it's more luminous than the light 6,000 suns would produce, and in just one emission line. Maybe then we'd discover even stronger masers. That's in the case that we're even going to be here at all. Because as the universe is getting hotter, cosmic radiation is getting stronger. Not so good for life on Earth. Increased cosmic radiation could harm us. Who knows if life would even be possible on Earth in that case, or if the powerful gravitational force would pull our home planet too, and crash it into another one. But maybe life as we know it wouldn't completely disappear. Or, if that happened, it could possibly somehow find its way once again, maybe in the distant future. There's a possibility our universe could support life at its early stages. Doesn't look like that when you think of the chaos the Big Bang caused, right? But that was only in its mere beginnings. After things had settled down a bit, the dregs of enormous, earliest stars formed rocky planets. In our solar system, those are Earth, Mars, Mercury, and Venus. You can't set your foot on the rest of them since they're gas giants. Back in that time, radiation was quite intense, so rocky planets had an adequate environment to form, since it takes a lot of energy to whirlpool dust and particles and bake a planet in the end. This period of time coincides roughly with that when the first stars formed in our universe. Ancient stars were way bigger than our sun. They lived shorter though. They would have just exploded as supernovas on their end, and they would leave heavy metals across the space around them. Those are the particles rocky planets formed from. Radiation spread around the whole universe back then. It has changed over time. Today, it's almost an absolute zero. 400,000 years after the Big Bang, when hydrogen atoms were forming, CMB was almost as hot as the surface of our sun. And about 15 million years after the Big Bang, its temperature was close to room temperature, which is around 80 degrees Fahrenheit. These things were happening across the universe, so there were many planets that could potentially hold life. If we were one of those ancient worlds, we wouldn't need a star to keep us warm. CMB would be enough to do it. So, it's possible that life in space is way older than we think it is. There could have been ancient worlds with liquid water on their surface. What if there were some primitive forms of organisms, like on our home planet a long time ago? Or even more developed ones? Perhaps we'll find out one day.
What can survive in space? Well, people can, if they have an excellent spacesuit. Spacesuits are, shall we say, kind of a needed item in the vacuum of space. Without one, you'll have to stay inside the spaceship or modular dwelling on the Moon or Mars. Currently, NASA has only several older spacesuits ready for use outside the spacecraft, like the International Space Station. NASA's Artemis mission to the Moon is planning to have new suits designed for both men and women. It has a $250 million budget for them. These new suits are much less bulky than the older ones and much more fashionable. But what other creatures besides people can live in space? 3 named animals were sent into space, and they all came home safely. Does that qualify? 2 dogs, Belka and Strelka, spent a day inside a Russian spacecraft in 1960 and became media stars upon their return. The USA launched a chimp named Ham on a 16-minute ride into space. Space starts 62 miles above the ocean level and only takes a rocket a few minutes to get there. Ham, who wore a spacesuit, performed all his button-pushing tasks admirably and is honored in the International Space Hall of Fame in Alamogordo, New Mexico. But tardigrades can actually live in space. Tardigrades, or water bears as they are often called, are brown and look like teeny tiny grizzly bears, and are one of the most miniature animals with legs. They have 8 of them. Most species of tardigrades have no eyes, but some do. It's possible to see water bears with a good magnifying glass, since they average about a ½ millimeter in size. Sprinkle a little water on moss and they'll come out. They can walk about 1 body length per second and run at about 2 body lengths per second. Water bear eggs are easier to spot because they're bright white. The European Space Agency took water bears to the International Space Station and left them outside for 10 days. They survived. They still survived with no air, water, almost a perfect vacuum, harmful solar radiation, extreme cold, and heat. Well, that doesn't sound very fun, does it? In extreme conditions, water bears rely on their exoskeleton, or tun, to protect themselves. In laboratory tests, this exoskeleton could withstand immense pressure at over 87,000 pounds per square inch. That's quite a spacesuit they got. Water bears have even been frozen solid for 30 years, and when warmed up, the water bears revived and were still able to reproduce. As we search for life in space, as we explore Mars, these types of extreme life forms become essential to understand. If water bears can survive literally every environmental condition, can we conclude that life is everywhere in space? Extremophiles are life forms living in extreme conditions, such as other planets might have. Movile Cave in the country of Romania is one such place that could just well be on another planet. All life on Earth, on the surface of the Earth, is carbon-based. It means that carbon atoms act much like a universal Lego block, to which hydrogen, oxygen, and nitrogen atoms connect to form the molecules that the cells of living organisms are made of. But not in Movile Cave. Movile Cave was sealed off at least 2.5 million years ago. The water that percolates up through limestone rock has formed a lake in the cave, a mix of hydrogen sulfide, poisonous and corrosive, and ammonia. What could live in this toxic soup? Well, sulfur-based life forms. An entire ecological system without light or photosynthesis exists inside Movile Cave. The food chain is built on chemosynthesis, microorganisms eating sulfur-based chemicals. 33 species of sulfur-based creatures were found living in the hostile environment of Movile Cave. Shrimp, scorpions, centipedes, snails, etc., etc. Movile Cave is an alien world deep underground full of sulfur-based life forms. If creatures like this exist in Movile Cave on Earth, what can we expect to find living in outer space? Bacteria. Bacteria can live in outer space, and fungi too. Bacteria form the base of the food chain, and bacteria have been proven to be able to live in outer space. In the 1980s, cosmonauts on the Mir space station complained that something was growing outside the station's windows and blocking their view of Earth. It turned out, upon inspection, to be bacteria and fungus, or fungi. The windows, made of quartz, were being damaged and weakened by what was growing on the surface. Fungi were also found to be eating copper on some of the cables. Mold was found growing in some places on the outside of Mir. The space station was under attack by microorganisms. Scientists took this very seriously and began to investigate. It seems that in a sterile environment such as space, bacteria come out of their hiding places when no other microorganisms are around. Cosmic radiation may even help them mutate and adapt to the space environment. The bacteria seem to be growing even faster in space than on Earth. Years later, the United States decided to run a bacterial experiment on the International Space Station. They coated rocks with various bacteria and put them outside the space station. Some bacteria did not survive the harsh conditions of space, but many did. One strain called OU-20 survived for over a year and a half outside the ISS. Japan also did a bacterial experiment on the International Space Station. Outside the Japanese Kibo module, Kibo's robotic arm placed 3 panels with the bacteria Deinococcus radiodurans, or D. radiodurans for short. It survived outside in space for 3 years. The lead scientists of the Japanese experiment calculated that the bacteria could live as long as 8 years in space. That's long enough to make a journey to Mars and back 4 times. Now, this raises a couple of interesting questions. Could life have come to Earth from Mars in a space rock? And, more pointedly, could an infectious bacteria come to Earth in a space rock? Suddenly, what had only been considered in science fiction books and movies was now a subject of intense scientific scrutiny. And then came the Mars meteor. Antarctica is the best place to find meteors because it's covered by ice. The ice in the Allen Hills regions of Antarctica is locked in place by the configuration of the surrounding mountain. The ice here sublimes. That means the ice evaporates, never becoming liquid but turning directly into vapor. As the ice in the Allen Hills region sublimes, it exposes all the meteors that have hit the ice over many hundreds or thousands of years. Meteor hunters literally drive around on snowmobiles and pick them up with tongs, never touching them to avoid contaminating them with human bacteria. They bag the meteors, number them, and record the location and any other pertinent facts about the meteor. That's how meteor ALH 84001 was found, the Mars meteor. Since Earth gets hit by about 17 meteors every day, over thousands of years the numbers add up. Almost everywhere has been hit by a meteor at one time or another. 11 years apart, 2 houses on the same street in Weathersfield, Connecticut, had their roofs punctured by 1-pound meteors. But only a rare few meteors ever come from Mars. 126 meteors have now been identified as coming from the red planet. ALH 84001 came from Mars. Scientists know this because the United States has landed on Mars and sampled Martian rocks and the Martian atmosphere composition. ALH 84001 contained the same gases as Mars' atmosphere and similar chemical composition as the rocks. But the meteor also contained something else, a fossilized life form. There has been much debate about whether or not the tiny object inside ALH 84001 is a fossilized bacterial life form, or rather a chemical deposit. But the studies aboard the International Space Station confirm that bacteria can live for a long duration in space. So it is entirely possible that some bacteria could make the journey to Earth from Mars in a meteor. The United States Mars Exploring Perseverance rover has recently found organic molecules inside Mars rocks. These organics are carbon and hydrogen. It won't be known if these organic molecules were produced by living organisms or merely by chemical reactions until the samples are returned to Earth sometime before 2030. The search for life on Mars is ongoing. But Mars is not the only place in the solar system that might have life. Jupiter's moon, Europa, is a good suspect too. Entirely covered by miles of thick water ice, Europa may have an ocean of salty water beneath its icy crust. Ice acts as an insulation blanket. Combined with possible internal thermal processes in Europa's core, means that Europa's ocean water could be warm. The Europa Clipper Express mission plans to confirm conditions for life on Europa. Loaded with 9 pieces of observational equipment, the Europa Clipper will attempt to observe just about everything possibly going on by orbiting above Europa, including the chemical composition of the mysterious reddish-colored material that has ejected onto the surface ice from the ocean below. What could this reddish material be? Could it be a specific chemical mix? Or could it be krill, shrimp, fish, life forms like in Moville Cave? Or the ancient remnants of a Brightside narrator? Stay tuned.
Our Sun. Scenario 1. Something strange just happened now. Every TV channel, the news, they're all talking about a black hole that came closer to us, on the spot where our sun used to be. You can even see an accretion disk, and the background of the sky looks kind of distorted, which means it got really close. Normally, black holes are so far away that we can't see them with the unaided eye. You can't even see them with a telescope directly. What's it doing here so close? And where's the sun? Did the black hole swallow it? The sun used to be in the center of our solar system, far enough not to burn us, but still close enough to give us light, warmth, and beautiful scenes when it rises in the east and goes to rest in the west. Hey, this one even rhymes. Well, it gave us life. The most massive body in our solar system contains 99.8% of its total mass. It's so wide, you could fit more than 1 million Earths inside of the sun. Maybe our sun turned into a black hole. but it's way too early for that to happen. I mean, that's how they form. When enormous stars come to the end of their life cycle and explode, which is called a supernova, they end up collapsing on themselves, becoming very small. It's a tiny size and a huge mass. That's what makes black holes' gravity so strong, and even light that comes too close can't escape. And all the stars in the universe are shrinking and will disappear at some moment. Our sun loses 4 million tons of mass every second, and eventually, the only energy left in the universe will be generated by black holes. A black hole is surrounded by dust, gas, and radiation. The radiation is very dangerous, so we hope our planet won't come near it. Our solar system doesn't have light anymore. No light and no heat either, so even Mercury and Venus will probably get covered in ice pretty soon, not to mention Earth. Do I need to say nothing will survive this new ice age? The only salvation might come from the accretion disk that spins so fast it generates heat, but that's too many chances to take. Still, at least if the black hole has the same exact mass as the sun before it, all the planets will remain in the same orbits, Earth included. But if it has a mass bigger than our sun, which is something our scientists are currently trying to figure out, then bye-bye, solar system. It was nice knowing you. Scenario 2. Oh no, what's happening? It was supposed to be a nice sunny day, but now you see darkness descending so abruptly. How come it's night, yet the clock says it's 2 p.m., and the moon looks different? The TV reports say our sun is gone, and due to some mysterious events, the moon is not orbiting the Earth anymore. It's in the center of our solar system now. We don't have much time left. Since the sun is not in the center of our solar system, we now have 8 minutes and 20 seconds to become aware of it. It may take millions of years for the sun's energy to travel from its core to the surface, but 8 minutes and 20 seconds is exactly how long it takes for sunlight to reach Earth. The light takes a journey across 93 million miles, which is the distance that separates us from the sun. We're not in the habitable zone anymore. The habitable zone is the distance from a star, in our case, the sun, at which liquid water could exist on the surface of a planet. Now that the sun's gone, its light won't reach us anymore, and our planet will gradually become a frozen, lifeless rock. Who knows if we'll have enough time to come up with some technologies that would provide us with the solar energy we need to sustain life on Earth. If not, well, millions or billions of years later, scientists from some other civilizations would explore it, trying to find evidence if life ever even existed there. It would be the same as we do with Mars and other planets in our solar system, trying to figure out if they've always been lifeless or if there might be a sign that some organisms used to live there. Something else, also vital for our life, travels at the speed of light. Gravity. Without the sun, for roughly 8 more minutes, the planets would continue circling the empty center of our solar system until the clock ticks and they finally drift somewhere into an unknown direction of outer space. Our moon doesn't have a strong enough gravity to keep us in place. It can't shine so brightly to give us warmth and support life. It's so far, we can barely see it now. Without the moon that peacefully travels close to our planet as it used to, we can see tides are getting lower incredibly fast. Oh, and it's becoming really windy. Winds are so much stronger and faster now. When things were normal, our planet sat at a 23.5 degree tilt, which is the reason we had changing weather and seasons. Now the tilt is so extreme, it's getting very cold, very fast. And our time is almost up. People are screaming, everyone's in panic. We still have maybe 1 minute left until we sink into eternal darkness. Scenario number 3. We're not sure what exactly happened and how the life we carelessly lived yesterday came to an end. No one could predict it, but it seems that, out of nowhere, a giant neutron star took the spot where our sun used to be. It's not something we'd recognize on our own. We just noticed something was different, and the sun kinda got smaller and weirder. The rest we heard on the news, and no one knows how it happened. Maybe our sun is somewhere behind the neutron star, or the star pushed it out of our solar system and into an unknown direction. A neutron star is the densest space object we know about. It has almost twice as much mass as our sun, but it's all squeezed into a star only 10 miles, 15 kilometers, across, which is about the size of a city on Earth. A neutron star forms when a huge star runs out of fuel. It collapses in a big explosion. its very central region, the core, collapses, which is why every electron, negatively charged particle, and proton, positively charged particle, crush together into a neutron, which is either uncharged or neutrally charged. We're in a very tricky situation now, basically waiting for our end to come. This neutron star has gravity 2 billion times stronger than the one Earth has. This means our new sun will pull all the planets in our solar system towards itself and eventually destroy them. It's already started. For the first time that we know of, the planets are leaving their stable orbits, attracted by the powerful force of the neutron star. It's becoming chaotic pretty fast. And it won't stop there. A neutron star rotates more than 700 times every second, which is incredibly fast. Our sun rotates once every 27 days. So, after it destroys all the planets, including us, this star will continue whirling throughout the universe at about 1/5 the speed of light. Maybe it will slow down and fizzle out with time, but maybe not. After thousands of years, many neutron stars begin to slow down and blow out. But that doesn't always happen. If it meets another star, it will orbit it and start to feed off its atmosphere until it collapses at some point and turns into a giant black hole. Our sun was going to burn out anyway. Until the neutron star showed up, the sun was 4.6 billion years old, which was about halfway through its lifespan. It had already burned off about half of its hydrogen stores and had enough supplies for another 5 billion years. It was eventually supposed to end up the size of the Earth. After running out of fuel, it would have simply collapsed. It would have retained its enormous mass, but its volume was going to be similar to that of our planet. No sun, no life, so the result would have been basically the same. But this way, it would have been a slow process. Who knows if humans would even inhabit this solar system in those times? But with neutron stars, things move towards the end pretty quickly, and it's way more chaotic. If the neutron star was going crazy somewhere far away in another galaxy, we'd only see it in the shape of a distant flashing light that we call a pulsar. But this way, boom!